This is an applied problem that involves distance, speed, and time. An airplane flew for 5 hours with a 20 km/h tailwind and returned in 7 hours against the same wind. Find the speed of the plane in still air. Well, we'll use the 5-step problem-solving process, and first we'll familiarize ourselves with the problem. Let's begin by letting d equal the distance traveled and let r equal the speed of the plane in still air, and these are in kilometers per hour. The r is in kilometers per hour, d is in kilometers. Now, we're told that when the plane travels with the wind, it goes a distance in a certain amount of time. If the speed of the plane in still air is r and the tailwind is 20 km/h, then the airplane speed with the wind is r plus 20 km/h. And when the plane travels against the wind, if its speed in still air is r km/h and the wind is 20 km/h, its speed against the wind then is going to be r minus 20 km/h. Now let's take this information and organize it in a table along with what we're trying to find. We are told that when the plane travels with the wind, it goes a certain distance, and we've decided to call this d. And with the wind, we've said that its speed is going to be r plus 20. And the time that it travels this distance d with the wind is 5 hours, so we'll put 5 in the time column. Now, the distance against the wind is the same as with the wind, so that's d again. And we said that its speed against the wind is r minus 20. And we're told that it takes 7 hours to travel the same distance against the wind, so we'll put 7 in that last slot. Now let's use the information in this table to translate to a system of equations. We're going to use the formula distance equals rate times time in each of these rows of the table. So from the first row, I know that d is equal to the speed, or the rate, r plus 20 times the time, which is 5. And using the second column to do the second row to do the same thing, we get that d is equal to r minus 20 times the time, which is 7. Or if we wanted to actually do these multiplications, we would have the system of equations d equals 5r plus 100 and d equals 7r minus 140. Now we're going to solve this system of equations, and we can use substitution. I can substitute 5r plus 100 for d in the second equation and then solve for r in that equation. So let's go ahead and do that in the third step in the process. Here I've substituted 5r plus 100 for d in the second equation. And now I'm just going to proceed to solve this. I'm going to subtract 5r on both sides, so I'll have 100 equals 2r minus 140. And now I'm going to add 140 on both sides. I get 240 equals 2r. And finally, I'm going to divide both sides by 2, and I get 120 equals r. Now, we don't need to go ahead and find d in this step. We're asked to find the speed of the plane in still air, which is r, and in the process of the check, we'll deal with the distance. So let's go ahead and go to the fourth step in the process, which is to check the solution in the original problem. Now, we're checking the plane's speed in still air of 120 kilometers per hour. So let's think about this. If the plane is traveling with the wind, and the wind is 20 kilometers per hour, its speed with the wind is going to be 120 plus 20, or 140 kilometers per hour. And we're told that the plane travels a certain distance in 5 hours at this speed. So in 5 hours, it travels 140 times 5, or 5 times 140 kilometers, and that is 700 kilometers. Now let's check what happens when the plane is traveling against the wind. Against the wind, its speed in still air minus the wind speed, 120 minus 20, or 100 kilometers per hour. And we're told that the plane travels a certain distance at this speed in 7 hours. So the distance that it travels would be 7 times 100, or 700 kilometers. And since these distances are the same, then we know that the solution that we found does check in the original problem. So let's go to step 5 and state the result. The speed of the plane in still air is 120 kilometers per hour.